Now let's generate the hyperbolic tan function using the Quadratic algorithm. Now in order to get the hyperbolic tan function, we can divide the hyperbolic sine with the hyperbolic cos. So we use this little identity here. Tan theta is equal to sin theta divided by cos theta. So we do it in two stages. We work out our sin theta and our cos theta in step 1. And then in step 2, we divide the sin theta with the cos theta, and it'll give us our tan theta. So we've seen step 1 in the previous video when we generated the sin and the cos. So this is a hyperbolic in rotation mode. We have our x0 equal to 1.20749, y0 is 0, the z0 is the angle we're going to use. Now again in this example, we'll use the angle of 30 degrees. So we'll be looking for the tan of 30 degrees. So the output of this will be the value xn, which will be the cos of theta, and yn, which will be the sin of theta. So those should give the values 1.14024 for the cos and 0.54785 for the sin. Now we can move on to step 2. In step 2 we're going to divide the sin with the cos. So we're dividing this number here with this number here. So we use the division algorithm, which is a linear vectoring mode. The input x0 is going to be the value for our cos, which is the 1.14024, and the input for our y0 is the sin, which is 0.54785. The angle z0 is going to be a value of 0. The final output is Zn is equal to Z0, which again is 0, and it's Y0 upon X0, so it just divides these two numbers out. So whenever we divide them out, we should get the value, which is tan theta, which is equal to 0.4805. So let's work through this in the graphical calculator, and we'll see whether we get this answer for the tan of 30 degrees. So this is our tan function here. Now we can also write that as sin divided by cos, so I'll put that one in as well. So you can see sin divided by cos is just exactly the same. Now we're going to use 30 degrees, but we'll have to change the 30 degrees into radians. So it's going to be 30 times pi upon 180, and that will give us the x coordinate here, which is 0.524. Now the y coordinate is the tan of this value, which is 0.4805. Now we're not going to work through this simulation again. This is the same simulation we used in order to generate the sin and the cos for 30 degrees. So the simulation gave us the approximate result, which is 1.1415 and 0.5501. So we're going to use those in the step 2, which we'll do next. So now we work through stage 2, which is our division, which is a linear vectoring mode. Now we've got to put our values in from the previous stage for our x1 and y1. So our x1 was 1.1415 and our y1 is 0.5501. Now we're going to have to subtract off and add on the angles in order to make this yi tend towards 0 because we're in the vectoring mode. So let me go ahead and I'll do that just now. So you can see the value for our y has tended towards 0. But now what we have to do is we have to generate the angle given by our Zn. Now I've already worked out the angles here, and I've already added on and subtracted them off, and we get these angles here, and that gives us a final angle of 27.528 degrees. So let me go ahead and I'll add and subtract those on just now. So this angle here is our ZN, and it's a value of 27.528145. Now, whenever we convert this into radians, we're going to multiply by pi and divide by 180, and it gives us our final answer. Now, our final answer is 0.48045, and that's close to the answer here, which is 0.4805. So I'll go ahead in the next page and I'll summarise the calculated results along with the simulated results. So these are the two steps that we went through. Now the actual calculated results are given by the cosh of the angle, which is 1.1402, and the sine of the angle, which is 0.5479. Now the actual simulated values are 1.415 and 0.5501. These values went into the second stage. Now the actual calculated value for the final output should be 0.4805, and with these values here we simulated 0.48045. So let's go ahead and we'll plot the final result. So we have our calculated result in white and our simulated result in pink. And you can see that the results are very, very close. So that's us now able to generate the hyperbolic tan function. That's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.